I'm not going to answer all of the questions that Rich handed to me. The answer to all of your questions for me is Rich has those answers. I want to use the concept of reproducibility somewhat differently. And so this is a real outlier presentation. Because I want to ask the question, how well does the language in which we encapsulate the science reproduce what it is the scientist is trying to say to us? And I'd like to ask you to start by looking at that second standing placard and ask you what it is you think that is. How many of you think that that is the traffic patterns in New York City? How many think it's some kind of a neural pathway? How many of you think it's a new galaxy configuration and that's actually black holes somewhere in the background? We don't really know, unless we are the scientist who's within that community, what's being telegraphed there. We can make some reasonable inferences from other kinds of associations. But when the scientist gives us language, we start to relate. We relate from our world and all the context we bring to that world. And when the scientist fails to get us to an understanding of what the scientist is seeing there, that's a kind of failure to reproduce too. And I want to focus on it and ask the question, are we paying enough attention to the ways in which we talk about what we know? And then to ask about the ways in which the media talk about how we talk about what we know. And in the process, invite also two other questions, because throughout the presentations in the last couple of days, we've been making some assumptions about the ways in which language is heard. And when we talk about retractions, the question is, what do you think the audience that is not us is hearing when we say retraction? Is the audience hearing that, say, up to 20% of those are people who caught an error and wanted to fix it? Or are they hearing retraction equals fraud? Well, what they're hearing is going to contextualize what they think about the scientific enterprise. And so the language in which we communicate to each other about the way in which we define the problem can actually increase the likelihood that the problem is misunderstood and that it's overgeneralized and that the public thinks that there is a crisis in ways that there may not be. In fact, it can increase the likelihood that the public uses the language of crisis and the press uses the language of crisis. We also use the language of conflict of interest, and we've conventionalized it. So we routinely disclose conflict of interest. I don't think we should be using that language. I think what we are trying to say is that there are some things that could potentially influence us as humans and how we relate to data, and we're going to disclose those relationships. So what's the difference between saying I'm disclosing a conflict of interest, which in the political domain suggests fraudulent interactions of some sort, influence buying of some sort, but in our domain means we're going to disclose the relationships that might have some influence on the science. So when we ask the question, what's the language in which we talk about the reproducibility as we've been using the term here, we also need to ask whether we're having ourselves be heard in ways that are consistent with what we're trying to convey, and have we conventionalized language that may get in the way of our doing what we actually want to do, which is ensure that we follow the norms that we should be honoring as we produce our science. So let me begin with an analogy. I was asked to talk about the fidelity with which media convey science. And so I offer you this image. The fidelity with which that dog supposedly heard her or his master's, that was their word, not mine, voice, was in fact the way in which we communicated the original concept of fidelity in communication. And the question was, could the dog actually recognize the quote-unquote master's voice? Well, there are other questions. Could the dog understand what the master was saying? Did the dog accurately get a sense of what the master was trying to convey? And I want to use that kind of as my backdrop metaphor as a result. And I do not mean to suggest that our audiences are dogs. I just don't have an equivalent picture of any human being listening to a Victrola. I'm looking at a three-step process. The process by which the science is encoded by the scientist, the process by which the media decode and recode the science, and the process by which the public hears it. And I'm going to try to talk about increasing the fidelity in each of those processes. First, let's look at the encoding process. I think we need to worry about the accuracy at this stage, and that is the fidelity between what's there for the scientist and what's there in the language available for the media and the public. And what I'd like to suggest is that there are times in which science really tells us it's thinking hard about this. This is the word prion, which didn't exist before Prusiner created the word. This is a scientist thinking about the language in which he's going to encapsulate what he is studying and what he thinks he's going to know. If we all adopted his care, I think we would have better scientific communication, because he coined the term to capture his finding that infectious proteins can cause neurodegenerative disease. That is, mad cow disease, BSE, Creutzfeldt-Jakob, etc. But what's important here is he decided that the existing language was not productive, and he wanted to communicate that proteins were at play. And so he created a new word, prion, and invites you to say, what's the pre in prion? And now we have a discussion about what it is he's trying to say. We haven't naturalized it, and with all of the naturalization, old assumptions. And, this is not good. It's just entered standby. Okay, well, while we figure out where it went, he actually talked about, it's up there. It's not on my screen anymore. He actually talked about, and it doesn't want to go back, he actually talked about wanting to disrupt the old language and wanting to communicate with some clarity. I think that should be our goal as we think about communicating science. And so when we call something swine flu, because there are swine genes, although avian genes, although human genes, someplace in there, we need to ask, what does the public take from that? And what the public takes from that can be problematic. It can, in fact, lead to bans on pork imports and slaughtering of pigs. So did the scientists intend it? No, but they weren't thinking about what we might infer from it, and they caught on fairly quickly and changed swine flu to influenza A, H1N1. Does the language invite a question, the answer to which is a scientifically accurate and useful piece of knowledge? Trevor talked yesterday about critical theory and also the theories in philosophy that go back to Sextus Empiricus in ancient Rome and Descartes, the radical skepticism that simply denies that we can know. Einstein inadvertently contributed to the confusion that was at the base of that discussion of critical theory when people cited the theory of relativity to say everything's relative. Now, Einstein didn't mean that everything was relative, but when he called it theory of relativity, general theory of relativity, that was an anchoring noun. And the problem with that was something that he recognized, but in the process it caused complications within the culture because it was mistranslated to us. He granted it would have been better to call it theory of invariance. Well, the critical theorists who were debunking the notion of facticity and the knowable would have had a lot more trouble suborning Einstein had it been called theory of invariance. In fact, they wouldn't have used it because it called into question the very presuppositions they were using to attack our capacity to know. GMOs, classic problem. The scientists actually adopted the concept genetically modified organisms, but they knew what they meant. They weren't talking about cross-pollination, they weren't talking about hybridization, and they weren't talking about mutagenesis. They were talking very specifically about precise editing. And nonetheless, they conventionalized genetic modification of organisms. To them, the knowledge was clearly communicated, the referent was clear. It moved into public debate and it caused all kinds of confusion. Now you've got the genetic modification debate and you've got the labeling debate. Those people who want to label all GMOs, literally, if they're accurate, are going to virtually label the entire produce aisle. And they're going to label us as well. So the person who's the consumer is going to be a GMO, because as you know, we have benefited from horizontal gene transfer, and so you can say that we are genetically modified organisms. Pity the poor legislator now who sees the massed citizenry needlessly fearful of genetically modified organisms because they're conflating them with pesticide use, and in the process, having to legislate in order to deal with the demand for some kind of labeling. Well, the first thing they have to do is to say, by GMO, we don't mean GMO. By GMO, we mean bioengineering, and they're going to define it. Here's the legislation that was passed and signed. Here's what it did. Here's what it said. This is the legislative process having to fix something the scientific process should never have introduced in the first place. We did not put into the literature the precision that was needed here to let the subsequent discussion be clear. Does the language carry unwanted associations? Herd immunity. Does anyone want to be part of a herd as part of creating immunity? Bah and moo. Go proudly, happy herd, says the Wall Street Journal.
Experts say that some communities requires 90 to 94% of the total population to get immunized. I just want to have so-called herd immunity.
Okay, 92 to 94% equals herd immunity. I am taking a deep breath now because I know that many of you are distinguished statisticians and I am not. But if you assume that everyone is equally likely to interact with everyone else, this makes some sense. But that's not how humans function. Humans function in environments in which there are some places in which you're going to have disproportionate numbers of people who are different from other kinds of people interacting. And as a result, you've got very high vulnerabilities within enclaves, even in a population that in general has 95% vaccination. So, for example, in some parts of Santa Monica and in pediatricians' offices because we can't vaccinate children under 12 months of age. So does the concept of 90 to 95% roughly and the concept of herd immunity tell the public what it needs to hear? No, it doesn't. But community immunity does, because community immunity asks the question, what's the community that has the immunity? And now we can say, you've got vulnerability in a pediatric office. You've got vulnerability in a school system. Even if the larger community has higher immunization, there's specific immunity problems within that community because of incapacities to vaccinate, et cetera. And so what you have is a policy debate in California, for example, about whether we should mandate vaccination that is more clearly driven by accurate language when the scientists have handed the label community immunity into the discussion rather than herd immunity. What you don't want is the person who says, should I vaccinate, to say, I don't really have to, because we've already got herd immunity, but they're walking their 10-month-old into a pediatrician's office with an unvaccinated child coming through whose parents have just been traveling to Europe. The child doesn't know he has measles. That's called the San Diego outbreak, and that baby almost died. Community immunity, however, hasn't taken on yet in the media stream. Well, it needs to, but if science had gotten it right to start with, we wouldn't have to be correcting on the back end. And does the language invite an accurate inference about the effects of efficacy? Here's a concept, the suicide gene. What would you guess a suicide gene does? You'd guess it kills itself. So if science says it's a suicide gene and it doesn't kill itself reliably, then it's not a suicide gene. It's a failed attempting suicide gene, and now we've got a problem for science. We also need comprehensiveness. When we first started talking about Lyme disease, we were inviting lethal fear of a town in Connecticut. When we added the word tick, we indicated the carrier. Once you've got the carrier, you can ask, do all or some ticks carry Lyme, and when and where are these ticks present? You also, by virtue of saying tick, will signal a mode of prevention, long pants and sleeves, insect repellent, checking for ticks after you've been outdoors. When you include bacterial, you're also signaling something else. You're helping to build schematic knowledge about insect transmission. Insects can carry bacteria. Insects can carry viruses. Lyme disease is caused by bacterium. Antibiotics may be effective in that case. So now you're beginning to build schematic knowledge out of a good label that is comprehensive as opposed to an incomplete label that invites you to stay out of Connecticut. Mosquito-borne sexually transmitted Zika virus. If we transmit Zika as simply Zika, we are suggesting that we should be fearful of a forest in Uganda. If we say Zika virus, ZIKV, we're at least saying it's a virus. But when we say mosquito-borne, and we specify the type of mosquito, Aedes aegypti, Aedes albopictus, we're inviting one to identify the carrier and inviting people to ask whether or not we've got those mosquitoes around here. We're also signaling modes of prevention, insect prevention, et cetera, through long sleeves and repellent. And when we say sexually transmitted mosquito-borne, now we're putting another piece of information in that carries with it preventive implications. So we're right in the middle of trying to communicate this. Do we communicate it in a comprehensive, accurate fashion or not? And that should be an obligation of the scientists who first talk to us about this, because the media tends to adopt that language as long as it's intelligible to an English-speaking adult. Values of including virus, fairly obvious. So Lyme tick disease is bacterial and treated with antibiotics. Zika is a virus, and as a result, we're trying to develop a vaccine. Now I can better understand why the NIH and CDC were pleading with Congress to please put the money forward to let them develop the vaccine. And now I'm starting to develop schematic knowledge that helps people understand that science has made an important distinction here, and importantly, that scientists know that there's a reliable means to deal with this. And now we can talk about science is reliable. Science has developed the vaccination that has eliminated horrific diseases. We can start to talk about those diseases. And instead of having a lost problem frame, we have a science is reliable and resilient frame. Consistency. Let's ask how the various agencies communicate what we know about genetically modified organisms. I'm putting that in quotation marks, and you know why. If we have common knowledge, then we should expect those who convey the knowledge to be using consistent language. Okay, here's the FDA, safe to eat. Pose no significant risk. This is USDA, the second agency that has regulatory power. There is no evidence that GMOs present unique risks. This is Law Library of Congress summarizing what they know. And here's the National Academy of Sciences, Engineering, and Medicine. No substantiated evidence of a difference in risks to human health between currently commercialized genetically engineered crops and conventionally bred crops. Now, you can guess why the agencies translated that into English, but there is actually a difference between those statements or among those statements. Ask the question which best communicates the science, and it's the National Academy of Sciences. But now ask a related question, which of these invites GMO labeling? And it's also the last of these. The challenge for communicators is communicating accurately and comprehensibly in ways that feature what it is we actually can say we know without tripping fears in a body politic in an environment in which advocates and self-interested parties have an interest in fanning them. So I focused for a moment just to make the point on this first kind of reproducibility, getting from what the science knows to what the media and what the public can grasp. And now I'm going to switch to a second space, because I'm going to ask, how does this stuff get decoded through the media? Problem. When the CDC says in 2000 the United States declared that measles was eliminated in this country, a reasonable human being engaging in ordinary language use hears, it's gone. Because that's what eliminated means when we talk to each other. But the CDC makes a distinction between eliminated and eradicated. That's the mistake at stage one. Now, the media ordinarily will take the language of science, if it's ordinary language, and this is, and will adopt it. But here's the media doing its job. This is what CDC means, no longer endemic. But here's the CBS site. Measles still poses threat to U.S. despite being eliminated. The media actually are trying to be faithful to the science. And sometimes the scientists are getting in the way, and sometimes the media step in and actually are performing the function that should have been performed initially in the scientific community. And part of the reason the media are able to do this is because they're talking to the public on a regular basis, and they can hear what the public is likely to hear. Here's the problem. You're getting two different signals. And here's the bigger problem, CBS was a real outlier. Which of those is most accurate? That assumes you know what endemic means, and now we're back to our original problem. To the extent that science is trying to communicate as accurately as possible in a context in which it understands what the public will hear, and is able to use the media as a conduit, those conversations between the scientists and the reporters are very helpful to the scientists, because they signal to the scientists that there may be a communication gap here that needs to be filled. We shouldn't situate the science in polarized space, and there's a tendency in media to do this. Here's how we got three-parent baby. You can imagine that if we have a three-parent baby, there might be some religious concerns. There might be concerns somewhere in the current political environment. Well, here's what the science originally was doing. And by the way, I think there is an underlying narrative to most scientific reports. It's, here's an important question. The question is this, it's important for this reason, and here's the answer. Aren't we excited that we know this? And here's how we know this. But there's another structure, which is here's the problem, and here's how we're addressing it. Here's the question we asked. Here's how we got to the knowledge. Here are the qualifications. Aren't we excited that we know it? It's, aren't we excited that we know it that is potentially the problematic piece of that. But what we have here is a problem. You have women whose mitochondrial DNA is carrying a devastating disease that can be passed to a child. Not a lot of moms, but there are some, and so that's a problem. And you can see why this is newsworthy, because it's a mom, it's a terrible disease, it's an affected baby, so there's potential news here. And there is a solution to this, a kind of elegant scientific solution. I've listed the elements up on the screen. Some of you know much, much more about this than others. All of you know more about this than I. And here's the first translation from the science. There are no three-parent babies here. This is a technique. And there is a contribution from three people. But when do you call the third person a parent? Well, the scientists haven't. Here's the technical write-up. There are no three-parent babies there. We're still in very technical terms. But the news media looks at this and says, horrible disease, terrible problem for the mom. Scientists saw a problem, and they have a solution. And we want the journalists to communicate this because this is science is reliable. This is the dominant narrative of science. The dominant narrative of science and media is not science is broken. It's scientific discovery. Isn't this neat? Is essentially the underlying theme underlying most media coverage of science. Isn't this neat? We can get this thing to travel through space. It's the size of a piano. It's gone X trillion gazillion miles, and it's going to go take a picture. Isn't this neat? Well, we want to communicate this. Isn't this neat? There's a problem, and there's a really elegant solution. Now, there may be some downsides to it as well, but nonetheless, you'd like it communicated. Press release doesn't have a problem. This isn't being hyped in the press release. Here we go. Media are trying to make it intelligible to the public, and they're playing out of the desire to find anything that situates in controversy and also report discovery. Scientists quoted in the New York Times saying, wait a minute, that's not accurate science. Don't do this. Mitochondria do not define who you are. The genes for traits that make up a person's appearance and other characteristics are carried in the nuclear DNA, and that's not what we're dealing with here. But the New York Times has put it in the headline, even though they put the scientist in the body, because they can't figure out how to get the headline to work to communicate what they want to communicate without making that translation. You might call this the media spin element of all of this, but what it's done is personalized, and what it's done is created a controversy frame. Here's the frame, here's the frame, here's the controversy. And now what we've just said is, scientists engage in controversy, and we invite the polarization of this area of science. We also, in the media, should be using language that elicit appropriate action and response, and so should the science. This is a study I find really intriguing. This is what effect occurred when the Japanese changed the words in Japanese to signal schizophrenia. It's 2002. The major society in Japan changed the term to reduce the perceived association between a mental health disorder and danger. Here's the change. I don't speak Japanese. I'm not even going to try. But there's a difference between saying mind split disease and integration disorder. And I think you get a sense that there is a difference. And that's the change they made. Here's what happened. The percent of cases in which patients were informed of the diagnosis increased. So the language changed the behavior of doctors. Before the name change, articles were associating the disease with danger more often than they were afterwards. The language matters. And in this case, science changed the names, press picked it up, Doctors changed behavior, verbal behavior, press coverage changed. The goal is to try to get that kind of alliance. So I started talking about prions. Let's look for the exact communicative language. I'm closing this block by saying, and let's try to see if we can get them aligned in a way that is comprehensive, accurate, and elicits appropriate responses from the audience consistent with the science. I want to make a second move. I want to ask, how do we predict the fidelity of media coverage to science? I'm going to suggest that you increase fidelity with common language, simple rather than nuanced and complex findings, common frames and common narratives. That means some kinds of science will never communicate well through media, and we ought to ask whether we actually want to do that or not as a result, because the capacity for misunderstanding is going to be high. Let's look at two reports from the academies, first on gene drives, the second on genetically engineered crops, and then we're going to drop in something which is the simplest alternative, something we did at my policy center. Here's gene drives. The problem here is almost insurmountable. Unfamiliar language. They don't simply have two unfamiliar words, gene drives, they have four, gene drive modified organisms. And they don't simply lack a common language in the headlines, they lack a common language throughout the entire news stories because the reporters are trying to translate these things into something the audience will understand. You also have change in descriptions, whether the media are going to call it gene drive versus genetic engineering method. And so you're not going to have the redundancy in the stories that's going to increase the likelihood of retention of attentive audiences. You also have a nuanced and very complex finding. Just look at the highlighted words from the first paragraph of the press release. The potential to, but, not ready to be released into, and. Look at the bottom, recommended collaborative, multidisciplinary, and cautionary approach to research and governance of gene drive technologies. Now, if you're a reporter, what's the verb you're going to attach to the study? There isn't one. They've had to get all of this in to accurately reflect the science. So here's the poor New York Times. 3 completely different headlines. What they're trying to do is to capsulize all that nuance, but you can't get it into a word. And they didn't. They got it into words that shifted across 3 places. Did they endorse? Did they support study of? Did they give limited backing to? The National Academies didn't give them the verb to tell them what they were doing. As a result, they had to draw the inference. Now, maybe we should have asked the group who put the report together, do you have a verb you'd like to put forward here so the press can simply take your verb? But in the absence of that, the press is going to struggle, and it's going to give people very different impressions of what is actually going on. There's also a lack of a common narrative. Here are very different narratives in the headline. A problem-solution narrative, which includes potentially addressing malaria and Zika, and organisms may threaten nature narrative. It's too soon to release them into the wild. And the closest to actually trying to capture what the report is doing, a relative benefit, relative risk framing. Of the 3, this is the one that's probably least likely to attract an audience, but it's also the closest to what the report actually said. So you've got some confusion. Let's look at the second. This is a genetically engineered crop report. Here it is, uncommon language, a nuanced, complex finding, lack of common frame, lack of common narrative. Uncommon language. Well, we've got this genetic engineering or GMO problem. So the report says genetic engineering, but the headlines say genetic modification GMO. Top one, that's the report. Bottom one, those are the headlines. You've got nuanced, complex finding. Anytime you say distinction between genetic engineering and conventional plant breeding becomes less clear, you know you've handed the reporter a nightmare. How do you put less clear in a headline and say that this is newsworthy? And yet, the comparative basis of this report is between genetically engineered or bioengineered crops and the conventional equivalent. So if your press release is starting by saying the distinction is less clear, but your findings are phrased in relationship to that pairing, you've got to ask whether or not the press is going to say, if it's less clear, why do you keep comparing them? Are you sure that those comparisons are still holding and still working? And then there's this finding. nor did it find conclusive cause and effect evidence of environmental problems from GE crops. Now, there's got to be some nuance in conclusive cause and effect as opposed to inconclusive cause and effect evidence. I know what the scientists are trying to say to each other, but I don't think that's going to translate back to the public particularly well. You've got a lack of a common frame. You've got a risk frame inside the report and its findings, and you've got a safety frame inside the reports by the news outlets. And as a result, you've got a really serious disconnect. Evidence here. This is the risk frame, and I've highlighted it. Here's the safety frame and the coverage. And much of this coverage is losing the fact that the finding was comparative. It is comparing genetically engineered with conventionally grown. So there's a real flaw if the science has not communicated that this is a comparative finding. It is not that it is safe, it is that it is, as best we know from these indicators, as safe as or as risky as risk-free as, depending on how you're going to calibrate those two. Lack of common narrative. Here are your differences. Are they safe to eat? Is there unrealized promise? Is there no apparent environmental harm? Now, apparent is important here because science isn't going to say no harm and science isn't going to say no risk. But the journalist's natural tendency is to say what the public wants to know is, should I eat them? Should we grow them? And so there's a natural flip from the risk to the safety frame, from the uncertainty to the what do you know frame. And finally, focus on the product, not the process, which is actually probably the frame that makes the scientists the happiest because it actually expresses how it is that they view this procedure. What happens when science has one narrative and you saw it? That's not a narrative that says we conclusively know these things about each of these areas. These are highly qualified findings. What happens when the reporter comes in with a strong press narrative? Here's a very strong press narrative. You can see it in the headline. Okay? You can see it in the person with the crops. You can see the date on the screen. What happens when you've got a strong press narrative is the scientific finding is subordinated to the narrative. So what's wrong with this article? What's wrong with this article is that, yes, the National Academy of Sciences report did find that there was little evidence that, but there's a whole lot of other meaning that has been ignored in this New York Times piece. It's here. This is the second paragraph of the report's executive summary. Now, does that look like what the New York Times report just said the report said? No, it doesn't. And the reporter has explicitly ignored this. So if you wanted to get down into the details, so why did the reporter select that segment? And was there an editing flaw in the report that let that sentence stand uncontextualized by the other reference that made it possible for it to be misquoted this way? How do you predict the fidelity of media coverage to the science? If you've got uncommon language in the science, if you've got, or contradictory language, you've got a nuanced, complex finding, if you've got a lack of a common frame and lack of a common narrative, you can guarantee that the media coverage is not going to do what the scientists would like it to do. When you've got a nice, simple finding, when everybody's got common reference, you're not going to have this problem. This is a finding from my policy center, and it is a simple finding. It has common language. It has just one little simple finding. It has a common frame. It has a common narrative. Everybody knows, or should know, or can easily be told what PG-13 means when we rate movies, what R means when we rate movies, and what we mean by gun violence in movies. We can tell you then that there are specific definitions of whether or not the gun is shot or not, whether you show the victim or not, whether you show blood or not. But you and I both know what gun violence means. It's a gun. And we got a common reference for gun. So common language is going to be a problem here. Very simple finding in pediatrics. Here's the simple finding. Common frame. It's a risk threat is increasing frame. There's increasing gun violence. And Here we get to something that David Allison has studied extensively. We get the benefit of white hat bias. The media believe that violence in media has to be menacing. It's a great story. It can be visually translated well into all sorts of people on screen shooting guns. That attracts attention from audiences. And as a result, this study is more likely to be published than if we say gun violence isn't a problem or gun violence is going down. We also have a common narrative. A vulnerable population is at risk from menacing messaging, and that's why we get the white hat bias, because the media believe this. Of course, we believe this too, which means we've got to be very careful in our research to make sure that we actually are seeing what we think is actually there and not simply seeing what we'd like to be there. But does it translate? Absolutely. Real clarity. Of course, there's no complexity here. Oh dear, this should worry me too. Headlines. It also translates into a cultural meme. So you know when you've got a common frame, a common narrative, and common language when you get a cartoon that goes viral. And here, what you have is Sound of Music. There's our study finding up in the corner of the cartoon, and they've all got guns. And you know Sound of Music is at least PG-13 if it's not G, and as a result, you know there's something really odd about this, and this probably isn't a good thing. But most science doesn't come this way. Most science comes with complexity and nuance and language that is technical and multiple parts, not some single finding. And as a result, it's not going to get the benefit of this kind of simple translation. But you get clear coverage. I want to make a third point. And now I'm coming back to the theme of the conference up to this point. How to increase the fidelity of the decoded scientific norms and its process to scientific norms in the process. The media brings assumptions to bear and frames to bear on scientific data. There's a negativity bias. It's not just about science, it's about everything. When politicians attack, the attack is more likely to get into news than when they advocate. As a result, the public overrepresents the percent of negativity in candidate speeches. Number of times someone on the floor of the House says something uncivil is actually fairly low. People believe it's higher than it is because whenever it happens, it gets featured in news, and it gets played and replayed. So there's a negativity bias. And there's a reason for that. The media are trying to warn us about things that might hurt us. So you can understand why they're doing it. There's also an attention value in it. We also process negative information more quickly, more deeply, and are more likely to recall it. There's a net commercial advantage to news featuring it. There's also a crisis bias. Why? Because it's attracting audiences. It doesn't attract audiences to say, tiny little problem which is being addressed. It attracts audiences to say, hair on fire crisis. And when media give us dramatic narratives of individual breaches of scientific norms, they run the risk for the science community that that vivid evocative narrative is overgeneralized because it's more cognitively accessible. And as a result, when you get the obicata stem cell, pluripotent stem cell retraction, and the ongoing dramatic narrative of that young woman and the investigation and the suicide of the senior researcher, and, the danger is people see that one moment and think all of science is broken, even though in most of the coverage that is not an explicitly invited inference. And when it was invited by scientists asked to comment who said things like, this is a death blow to this area of science. So it wasn't something that the reporter put into his or her part of the narrative. It came in through the scientific voice. And then finally, there's a real accountability function in media for which we ought to be profoundly grateful. So I'm now at this stage. Here's just reiterating there's a negativity bias. The implication is consequential retractions and instances of fraud will play into this bias, but they will be consequential instances. Most retractions get zero coverage. The ones that get covered are the ones that are consequential. If the pluripotent stem cell research was right, we could have sidetracked the embryonic stem cell debate because you wouldn't have needed embryos anymore. That's a really consequential finding. And there were people with illnesses who looked at this and said, there's a potential cure here. So was that consequential science? Yes, it was. Was that retraction consequential? Yes, it was. And news did its job and featured it extensively. Media tend to treat multiple instances as a pattern and generalize them into a crisis. The implication is that instances in which science fails to replicate or evidence that retractions are increasing will play into the media crisis narrative. Media activates the availability heuristic, just explained it. Let's look at how scientific norms are covered when they're breached. Consequential retractions. The typicality prevalence of the instances covered are not part of the normal news structure. Here's the avocado retraction, that's the pluripotent stem cell retraction, that's the definition of what had occurred, that's the journal that retracted and published, not in that order. Of 52 news accounts, only one explicitly noted that retractions are rare. When the scientists had a chance to respond, the scientists did not point out this is science self-correcting. Science caught this one really quickly. And the self-corrective process worked really effectively. That's a retraction that happened roughly within a half year of the time the publication came out. And PubPeer had critiqued that thing very effectively, very quickly, within days. But the self-correcting narrative wasn't there, in part because the only space the scientists speaking for the community had to speak, it didn't speak the language of self-correction, or if it did, it didn't get it through. Let's look at the Lacour-Green retraction. Summary of what that is here. This is interesting because the finding was replicated in subsequent science. And so the finding wasn't wrong, it just wasn't verified by this instance of fraudulent science. But here's an instance in which we're not saying that what they knew was wrong. When the next study is published and shows it's right, you actually have an instance of science engaging in its own process of ensuring the integrity of its research by catching the stuff that didn't establish it, but producing the stuff that did with methods that had integrity. But only 10 reports treated the retraction as evidence of scientific self-correction, and only 4 noted that retractions are rare. So, if the scientist sees retraction, wow, look, science is self-correcting, but the media sees it as, well, science is broken because of the operation of some of these personal heuristics in audience sometimes because the scientific voice is implying it, then the question for the public is, at what point does it say, can I still trust science? Let's look at the framing of prevalence. It may be that a lot more things should be retracted, but at the moment, the best available evidence is that very, very little, even with the rise in retractions, is actually retracted. Now notice, I'm not flipping this around and saying, as a result, 99% of our findings are solid, because we can't say that. But we need to find a way to frame this fact as science in general has proved itself to be highly reliable in places that we care about, and science is self-correcting. And this process of examining is a way to try to improve the methods that we have, the ways in which we approach this kind of knowledge to increase the reliability of the science. Replication and self-correction in science. So failure to replicate, scientist says, science is self-correcting. We're catching it, we're uncovering it. Trouble at the lab is the headline. I love this piece because it teaches so well. So trouble at the lab. Scientists like to think of science as self-correcting. To an alarming degree, it is not. This article contains more instances of self-correction than any other article we have ever found. The headline is wrong. Generalization to crisis. And then what is the underlying narrative that I'd like to leave you with? Science also benefits because media are vigilant about holding science to its norms. We all feature Wakefield. Many of the flaws in the Wakefield research were discovered by a journalist. So we ought to applaud when science reports how the sugar industry shifted blame to fat, and we ought to applaud the fact that it looks to see, do we still have a problem? Now, whether it's right or wrong about that, that's the journalist trying to hold us accountable. And we ought to applaud the study that happened the report that happened a couple of days ago that says years of ethics charges, but star cancer researcher gets a pass because it asks the question, who's giving the star researcher a pass? Should we be doing better? There are individual frames for most of this, not systemic frames, not science is broken, but individuals have problems. And there are heroes and villains. In the piece on the cancer researcher, there are whistleblowers. There are people who stood up for what science needed to do. There are people who engage in correction, but the dangerous narrative for science and one it needs to correct. There are also self-interested institutions that protect their own. Is there a problem frame or a problem solution frame? The frame that we should be advancing and we should make true is science is self-correcting versus it's working to surmount challenges, although I'd prefer challenges to problems, versus science is broken but still able to produce reliable knowledge, versus science is broken but is addressing and will surmount the problems, versus science is broken and no longer able to produce reliable knowledge. Pick one. Which one would you like to be our narrative? I'd like to pick 2. Science is self-correcting, but where it is broken, it is working to correct. Partisans, of course, are going to capitalize on all of this. They're going to generalize, and they're going to use it to discredit any inconvenient science. Wild overgeneralization. Here's what we need to do. Share common language frames and narratives. Communicate consequential complexity and nuance. Make sure they're not lost or distorted. Honor our norms, and hold ourselves accountable for honoring our norms. We want the audience to get it right and Rover to get it right, and we don't want to miscommunicate. And if we do, we want to make sure that the framing of it increases the likelihood that we act appropriately. Which headline do you want? I want the last one. Self-correcting science addresses trombone, and I'd put crisis in quotation marks. I'd be happy to take questions.